I'm Charlize, and this week I have Physiology and Experimental Psychology. A little background of the progression of science in psychology. Science started growing in the 16th and 17th century, and that translated into the 18th century. And that meant that psychologists started to gravitate more towards scientific explanations rather than philosophical ones. So we can see that. We start at philosophy, then we start seeing the change with science and physiology. And as time goes on, start researching and experimenting with bodily reactions such as sensations, movement, eyesight, touch, things like that. And that's when the idea of psychophysics gets introduced by Fechner. And psychophysics is the relationship between physical stimuli and mental phenomena. And that leads us to experimental psychology. Psychology and experimental psychology are both different things. You kind of can't understand one without understanding the other, so they go hand in hand. Physiology is the foundation for experimental psychology because it opened up the exploration of how the world is sensed and felt within the nervous system, and that translated to experimental psychology by studying how behaviors and anatomic structures of the body influence each other and proving it scientifically. Other things such as creation of laws and methods through psychophysics could provide explanation as well. Here are some different discoveries of the 18th century and some of the popular influencers. There are a few that I didn't mention, but these were the ones that stuck out to me the most. Charles Bell and Francois Magendie. The Bell-Magendie law proved that nerves could no longer be seen as conveyors of spirits or vibrations, and previously Hartley and Descartes had mentioned that, so Bell essentially proved them both to be wrong. He did this by operating on rabbits. Be grateful we're not rabbits. Bell was able to distinguish that sensory nerves enter posterior dorsal roots of the spinal cord, and motor nerves emerge from anterior ventral roots. And it explained how sensory and motor tracts are separate, but they can also be in different regions as well, such as the brain, spine, things like that. Hannes Mueller created the doctrine of specific nerve energies, and that expanded the Bell-Magendie law by showing different types of sensory nerves and how they respond in their own ways and have their own reactions. For example, eye to light, ear to sound waves, skin to pressure, smell would be scent, things like that. A quote I found to be interesting was, "Our knowledge of the physical world is limited to the sense receptors we possess." We have Hermann von Helmholtz. He created the principle of conservation of energy. The explanation for that was food and oxygen. It accounted for the total energy an organism uses. The rate of nerve conduction, that was actually discovered by using a frog's leg muscle and stimulation. So what he did was he took a frog's leg, and stimulated it and saw how long it took, so timed it. But eventually that was found to be unreliable because it was too slow. And of course that measurement had a variation within different subjects. So if you were to try it on a human, it would probably be different than a frog. We have Gustav Fechner. He lived a very full life, and as we saw in the lecture, he kind of had a Jekyll and Hyde personality with Mises and materialistic writing and his pseudonym name. Elements refers to the book he wrote called Elements of Psychophysics, and people still actually use that book today as references or to teach off of. Fechner had a eureka moment one day and said, "I know how to measure sensation. We'll measure it the same way we measure everything else in physics. We'll measure it by using the null matching procedure." And psychophysics revolutionized into experimental psychology, and he was essentially seen as the starter of experimental psychology. And he had his 3 psychophysical methods: method of limits, method of constant stimuli, and method of adjustment.